Did y'all write down questions you have? Are there any questions? Huh? No? Okay. You have some? Okay, good. Anybody else? Okay. All right, so letter A, it was pointing to that small box, right? What does that represent? TFT. That's your word dump, right? Because everything else matches up to the bigger area, which is the sensing area, right? Okay, so TFT, what are other names for that little area of the Dell? Non-sensing area. What else? Storage capacitor. Good. Okay, so number 2, the amount of absorbing material that will reduce the intensity of the X-ray beam to have its original value. Did you want to put filtration? It's half value layer. Was anybody thinking to put filtration? Just because it's in that family. But filtration is the process that makes it reduce. But the definition fits half value layer. So you got to know the best answer. And I put that on purpose because that's how you're tested, right? Registry does that. They're going to give you 2 final answers and you're going to try to, you're not going to be deciphering because you're going to know it by then. But you kind of decipher and then you got to pick the best answer, the one that really fits it, okay? Oh, I didn't want y'all to miss this one. Blank is the most popular half value layer filtration material. Now it's putting those 2 words together. What is that one? Aluminum, right? If SID is decreased, we're going from 72, this is my IR, 72 to 40 inches. IR exposure will do what? Increase. What formula does that fit?
The reverse square law.
Inverse square law, right? That fits that. That proves that, okay? So don't forget that. This is how you have to apply your knowledge. Or it could just simply be that question and say, what formula does this fit? Okay? Y'all listening, Amanda? Okay, if MAs is double and all other factors remain the same, what happens to IR exposure? It increases. Specifically, what will happen?
The intensity.
Yes, all of those things, and then it'll increase the same amount, double as well, right? Everybody understand that? You sure? Remember I said as I increase my MAs at the console, the same kind of MAs or electrons coming across and then photons coming out is the same, right? It'll double. Y'all got that? Okay. What is the grit ratio formula? I'm just looking at this paper because I'm like, we didn't go over this formula, but good. I'm glad that your eyes are on a formula, but not that formula. So what is the formula for a grit ratio?
Height over distance.
Height over distance. Remember I said HD. Remember?
I was like,
okay. So y'all gotta study. You gotta study. The number of grays a pixel can hold is termed
Grayscale
bit depth, right? Okay, so let's talk about what the other ones apply to. Window width. Y'all remember one term that goes with window width? If somebody says it. Contrast, good. I was about to say if one person can say it, I'll give you a point, but okay. Many people said it. Good. Window level. Brightness. So window width, contrast, window level, brightness. Good. And then Dell was on there. Okay, y'all. Because as I was walking around, I was like, no. Y'all are going to get it, though. Y'all are going to get it. As the grit ratio increases, so instead of a 5 to 1, we have a 16 to 1. What happens to IR exposure?
It decreases.
If you say increase, you got to explain it to me.
It's because you have to have more power to go through the grid.
Okay, and the reason why, thank you for explaining. The reason why I told you to explain it is because I wanted to see where your head was. So remember, what does grit ratio, what do grids do, James? What's the purpose?
Reduce scatter.
They reduce scatter. Now,
Make it more clear.
in a way, yes. They reduce scatter so that you can, so that the image is clear, yes. So you have it right. You said it absorbs scatter. That's what grids do. However, and I'm saying this for everybody, not just picking on James. You're okay with it, right? Not picking on James, but y'all will start to enter words. It's asking one thing, you're going to enter your own words. It said nothing about energy, right? Grid, you just said what grids do, but y'all grids have nothing to do with energy necessarily, right? Grids absorb scatter. So what happens to the intensity, which is what's intensity mean?
The
Number of photons. So if the grid ratio is higher, what happens? What's the difference between a low grid ratio and a high grid ratio as far as absorbing scatter? Which one is going to absorb better? The higher is going to absorb more, right? So if it's taking up a quantity of photons, which is scatter, still a quantity of photons, you're going to have less IR exposure, right? With the high grid ratio. That makes sense?
So you're saying it decreases?
It'll decrease. Mm-hmm.
So it's not
It's
So
decreasing.
I think I-
whenever we have like a grid, you're supposed to increase the MAs.
You increase the
It's
MAs,
about IR exposure.
but it's just talking about our exposure. So you see how you're entering words just because you have this knowledge now, but apply only what the question is asking, right? So, it says, as the grid ratio increases, IR exposure blank, so it decreases. Okay, so 5-to-1 versus 16-to-1, you ask yourself with this, okay, it's talking about grid ratio. Which one is going to absorb scatter better? So which one is going to take up more photons? That's a 16-to-1. So IR exposure is going to be decreased. Does that make sense? Okay. So there's going to be a lot of relationships, and you see how I have to, even as an instructor, because there's so many, if I look at questions or if I make up questions before I write them out or whatever, I have to say, okay, just what I did is what I say in my head. Because I don't know what's presented, I have to read it and I have to apply it just like y'all do. Does that make sense? Okay. All right, as collimation increases, we said that. As collimation increases, IR exposure, right? There's less getting to the IR. If you have it open, collimation decreasing, there's more photons, more IR exposure. Does that make sense? Okay. It gets easier, I promise y'all.
So
It'll be second nature.
So collimation increases, the IR exposure decreases.
Say that again.
You said collimation, when it increases, the IR exposure decreases.
Yes, but you gotta know your increased collimation versus decreased collimation. Okay, don't forget that. The PSP that is used in a CR's imaging plate is a blank fluorohalide compound that is doped with europium. Barium. And even if y'all didn't know the word europium yet, because that's in that word dump too, you just knew that barium went there, right? So you were able to solve the problem, okay?
What about the collimation question?
Yeah, that's the one we did. As collimation increases, IR exposure decreases, right? So if we have it wide open, that's decreased collimation. Students get that mixed up, huh? It's decreased. No. Yes, as collimation increases, I know it sounds backwards, right? As collimation increases, IR exposure decreases. Okay? So you can almost, because you're going to have to come back to this, and you may not remember off the bat. So take your time and say, okay, collimation is this. If I increase it, I got to go this way. Because collimation already means restriction. Let's restrict it more. That's increasing the restriction. Okay? All right. How do y'all think y'all did? Amanda's like, no. But you'll get it, though. You'll get it. I promise you'll get it. Okay? It's a process, y'all. Give yourself some grace.
I'm gonna start crying before you.
Don't cry.
No, it
Don't
was
do
a good
that.
day.
You're still here. Oh, a good cry. Okay, you can cry if it's good. You might need to cry if it's bad too, if you want, just to get it out. I get it. But just know that you're still gonna be here and y'all are fine. So I'm gonna put y'all in groups. Y'all like groups or y'all hate groups?
We can do groups.
They're okay.
Let's try it.
But there's the diary is like, I don't
We're
like
gonna
groups.
do groups based on our table.
But why do we do groups, y'all? Why do we put y'all in groups sometimes?
Bounce ideas off each other.
Bounce ideas, but y'all are gonna have to work in a group, right? As a team in our careers. So that's why we do it. Amanda, you like groups? Yeah. Okay. All right, so group 1, group 2, group 3, the back table. So 1 is 4 y'all. 2 is the third table. 3, the back table. Y'all got it? Okay, 1, 2, 3. And then 4. I didn't want to do this many groups. 5, 6. That's okay? Okay. So we'll have some groups of 3 and then some of 4. Okay? Y'all got your numbers?
Are we fine?
Huh? No.
Are we
One,
combined?
two. Y'all
said
be
four.
combined back there. I don't want to do a
You
group
said,
of
I think
5.
you said 4, 5, 6.
Yeah, cause they're in a group together.
Yeah, sorry. I wanted 3s. So do.
We can absorb these.
I'm confused.
I don't mind
That's
doing a
too
group
many.
of 5.
Yeah.
I had 4, 4, 4, 3. That's how I had it. So 4. Somebody's gonna have to shift.
4.
Okay, Nadira, can you come up here for me? Okay. So let's do 3, 3.
Where's the third person up there?
Nadira's coming.
Oh, okay. Sorry, there's no crowd.
Stacy, can you go 1, 2, 3, 4? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3.
Oops, sorry.
So you got 3, 3, 3.
1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 3. Yeah, that's cool on this side. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. Okay, y'all got it? So y'all are fine. 1, 2, 3, 1, 2, 3, 1, 2, 3. So just y'all 3 back there. Okay? We got it? Okay, good. All right, so chapter 13 is not within here, but we can kind of browse through it. I think, did we highlight chapter 13 yet? Okay, so we'll backtrack and just highlight. Not gonna be on the test. I did say that, right? Chapter 13 will not be on the test. Well, I still wanted you to study it because I did say I was gonna post something. So, yeah. I am still gonna post. Sorry. What about chapter 6 will be. Chapter 13 was just it's important. You'll see that stuff on the registry, but just because I felt like lab had to be, to me, it was just packed in and I wanted it a little more spaced out, but our class is so tight as far as lab time. So 13, I'll just do like a non-graded assessment just to make sure you know it. Okay, but it won't be on, that's the only one that won't be on the test. I'm taking that one out.
So 6 is not.
Right, but I still wanted you to know it, so I'm glad y'all still stayed.
So
Okay.
we pretty good on the what quizzes?
No. Sorry. I wish. But why do I say no? Because we have to know that y'all know this stuff for the registry. And if we give y'all points here and there may be times here and there where I throw like 2 points at you or something, but we gotta make sure y'all know it. So if we point y'all here and there, y'all are gonna get points and it's gonna look like y'all know it, but y'all don't. Does that make sense? So that's why we can't. You know, and we like to explain that because some students are like, they don't ever give us homework that we can just, no, because we can't. We'll give y'all homework for resources, but not for grades, okay? So, this is what I'm going to do, okay? Y'all are going to have to kind of come up here. It's y'all's turn now, because I want to see what y'all know. So, I had a student one time, recently really, because I tutor on the side, but she said, I like, and these students are like everywhere. I had a student in Alaska, but she said, I like to get a whiteboard and just draw, just dump whatever is in my head. I like to draw out things because you'll see, especially next semester with equipment, it is going to be stuff that you want to draw out. So think about that as a tool too. Maybe a little small whiteboard, you know. Don't go out and invest in nothing crazy, but so this PowerPoint includes just words on the screen where you got to get up here and write as a group, think of some things and dump it on there or draw. And then everybody else take notes, of course, and then it may be a question that you have to answer. So just depending on what it falls on, that's what your group will have to do, okay? What questions do we have before we start?
Yeah, so I was going over the LUT. Is that the same as the histogram? And then can you explain about the part where it says you have wrote at the CPU, the processing part?
Yes. So let me go to this. I just posted this. I want to show y'all this so you can get a picture. Let me just go here. Easier than going through all this stuff. These are the only 3 chapters that have all this stuff just dumped in here, y'all. So I think y'all will feel a little better after this. But then y'all will feel good because y'all will be kind of prepared for next semester. So and for 1065 because it repeats itself. Okay, so to answer your question, Ari, let's go here. Okay, so you know, as x-rays hit, these are your detectors, right? As x-rays hit here, you have this whole process, and then before it gets, this actually like simulates the monitor. So there's a step in between here. So there's a detector. This is that last layer, that electronic component of the Dell. And then when it says digital image, that means it's on the monitor. But then this middle section is the processing part. Like you have with any computer you purchase, you have that tower where all the information, the bits, whatever is in there, right? And then you have your monitor, which is what your eyes see. Okay, so this middle section would be your processor, that CPU. So right here, I kind of drew it out for you. So this is gonna make more sense, maybe looking at this. So this is what we just saw, that receptor with its layers. And then that arrow, that middle section, is gonna be here. And then that, where it said digital image, that's here. Does that make sense before I continue?
It's kind of like a printer. Like you scan the image and then the printing part is.
You can say that, yeah, is the monitor, right? That's
the
what you mean?
actual printed image is the monitor, but whenever
Yes.
it's in the process of printing.
Right, before you see it. There's something that has to happen inside that we don't see, right? Or we don't even care about, right? But now we have to. So yep, that's a good way to put it. So this is analog to digital converter, and then eventually it goes digital to analog, because analog, your monitor is actually analog. We'll talk about that later. So your CPU part, the tower part, like she said, before you see the image, before it's printed, when it's scanning, it does all this stuff. So automatic rescaling consists of the first step after it's at that stage. You have your histogram first, Ari, and then your lookup table is the next step.
Okay.
So it's 2 separate steps.
Okay, and then I know the histogram is the patient's anatomy, but it also does the same thing that LUT, which is the brightness and the contrast, is that right?
Yes.
Okay.
Yep, you can say brightness for histogram, let's separate it, and we'll get more in detail. So just an introduction, and then LUT is brightness and contrast. I'll show y'all how to answer questions like that, because a lot of times they focus on LUTs as contrast. Okay, so really we're gonna say right now LUTs goes with contrast.
Okay.
But all of that happens within here where they control both. So, and on some scale, both happen under both of them. So LUTs, contrast is our focus with LUTs, histogram brightness. Okay. I don't want to confuse y'all with that because it is on here, but.
So you said histogram would be first and then LUT.
Yes.
Right.
Mm-hmm. So as long as you know, we talked about, now where would window width and window level, what section would that go under?
LUT.
Well, because remember, so let's separate. So brightness and contrast, right? You see how that kind of controls that. But remember, this is pre-processing. When you hear window level and window width, post-processing. So window level and window width is what you, like even on your phone when you kind of go like that to filter your picture or whatever you're doing, that brightness and contrast is changing. That's your post-processing. Those are monitor features. So I thought I had that listed under here, but we'll write. So post-processing, I'll fix it and repost it. Post-processing would be under here, and you would put window width, window level. Okay, I don't think it's gonna let me do it on there. Okay. Okay, so I'll repost it. So yes, this says contrast and brightness, and we know the difference between window width and window level and what those control. But when you see the word window, that goes over here. You see window is not in this. Okay, Okay, windowing is just literally changing the window monitor function. Not the damage, but this gets you this. You can manipulate this a little bit with windowing.
So
Okay.
what all is in post-processing, that display and the windows?
There's a few terms under here that you don't need to know yet, but window width and window level right now is what would go under post-processing.
That's the only post-processing?
For right now. Yep, because you'll have a whole class. So there'll be other terms, so we'll just bring this back up and add to it. So you're gonna be ahead of the game. And just remember window width contrast, window level controls brightness. Separate those under post-processing, okay? Does that make sense? Y'all got that?
Yes.
Okay, everybody got it? Okay, any other questions? That was only, I'll come back to you, Art. Maya?
Were we doing the build factor, like the increased sensitivity? Or did you skip that part?
I did not. I just said the relationship. I have it on here. So this is a study guide for y'all. Okay. And I just put, where did I put it? If I left it off of here, then I think I have it. Yeah. A higher fill factor equals increase in detector sensitivity. And I put what it means, that it just means that you can accumulate. Because where's your fill factor? Like what area of the Dell is your fill factor?
The bigger one?
The big area, right? So the bigger that area, the more sensitive. It just means the more exposures can be put in there. The more of your picture can be put in there. That's all it means. Huh? Yes. So as long as you know that relationship. Yep. Uh-huh. I'm coming back to you, Michael. I see.
So, did you say that window width went with LUT, or it's like histogram, LUT, and then window?
Right. Histogram, let me go back up. Histogram, LUT is the next step in this processing part. So you have coming off of the Dell. Now that binary digit, everything's being transferred to your tower. First step is histogram in your tower. Then lookup table. Then that's pre-processing. So before it gets to the final stage, pre-processing, and then monitor post-processing. That would be window width and window level. So you were right. It's the last thing you said. That makes sense? Who, Michael, you had a question?
Oh, do we have access to that?
Yep, I just posted it for y'all.
Oh, man.
Oh, okay.
I didn't see it. Do I need to refresh?
Yeah, you can refresh it. You should see it. Cause I went under your student thing and I saw it. Go back out and see if you see it.
It's on there.
It's on there, okay. Was that good, Emily? Okay. Anybody else? No, for sure. Okay. Did you have another one, Ari? Okay. If you do, just let me know. All right, so we ready? So first group. I should start back here. First group. Y'all ready? The four of y'all, right? Okay. All right, come on up. Y'all got a word jump. Y'all got to write words, 1 word, 2 words, whatever comes to your mind to help you remember this. But you know what? I got to figure out how to write it on here. Y'all can type it, but I want you to type it. Like, I don't know how to without the whiteboard. You have to figure that out.
You should be able to write on there. Go to design maybe.
That was like the change in the PowerPoint.
Yeah.
I'm gonna figure it out. Okay. Y'all can type then. Yeah, I'll let y'all type.
You don't have like the option
See?
for the pin anywhere?
Right here, huh?
Go to home maybe. And then.
Oh, yeah, yeah. We're getting closer. Cause this is connected to the whiteboard, really, you know?
What's the quick styles? Yeah, it says drawing. Quick styles is under that.
Yeah, this is connected to the
Go
whiteboard.
to editing maybe. We can use the highlighter.
Under arrange, it says drawing. But I don't know if you can click on it.
See, it just goes to the whiteboard.
X is the top right.
I'm gonna figure it out, cause we gotta, I like to be on here,
We can use a permanent marker and
so. Wow, we could use a, dry erase.
Really?
Oh, I have one.
Yeah.
On there?
You do?
Yeah.
I have one in my office, but no one uses it, so.
Will it erase it? Oh, it's a
I'll
dry
make
erase.
sure
This is
too.
a dry erase.
I might scan this.
Okay, y'all don't get me lying.
Are you?
Do the quarter real quick.
See? I'm like, see, I don't know y'all.
Okay.
Oh my gosh.
Okay, that's cool.
No, I don't know, I'm scared.
Oh, okay, yeah, yeah, you're right.
No, but what if it like leaves a, what y'all think? I'm scared. Let's try it. I'll figure it out
Does
for
this one
y'all.
have a whiteboard on the back of it or something that's light?
Yeah, y'all wanna do that?
Yeah.
I wanted it on here though. Yeah, I have used this in lab and wrote on it.
Yeah, that's right. I don't think that.
I created, I made a whiteboard.
I don't think that.
Yeah, I've done it before on that. I just do stuff.
I know how to add the draw tab on there if you would like. For this, like there's a tab that goes in front of design that says draw, but I just have to click on something. I don't know if you want me to go in there and
Well,
do that.
see, the thing is,
But-
it's the pen that's connected to the whiteboard.
Yeah, no, I know, but like there's a way to do. Here, I'll show you.
Yeah, if you can show us. Yeah, whatever's in your head about that.
It's just like there's an actual like tab that's on here that's different than this.
Yeah, yeah.
The other one's how accurate.
Well, I don't know.
Yes.
Do like slide.
Oh, you got it?
Yeah.
Okay, so let me step right here while you're our tech here. Okay, so. So y'all agree? Step aside for a second. So efficacy, accuracy, or trueness is another word. Trueness of the image. Does this really simulate the patient's anatomy, right? And then yield, is this clinically useful for the radiologist? Y'all know that? Yeah. Got it? Easy peasy, right? Okay, good. Uh-oh, now I don't want to get in trouble now.
No, you're not.
Okay,
It's not something like that.
Miss Anderson, can the other groups know our questions so we can work on it before we go to the board?
No.
It's
I want to know what's in your head. That's why I just have them pop up. Because y'all are going to work together to see who knows what, and then we'll all help. So, yeah. And then later on, I'll post this. Y'all can go back through it and, you know.
Is there a way to post it if like we do get the drawings on?
So we'll just cancel. It's okay, because we can draw on there from in the app, but we can't draw because it's connected to the whiteboard. So we'll cancel.
Yeah, I didn't change it.
Oh, okay. All right, so y'all so y'all know the difference. Okay, so
Yeah, because
we can't be cheating and letting them know what's ahead. So good, y'all got it. Anything else y'all got to say about it? I think that's it. Okay, very good. Good. All right, group 2, y'all ready? Is that easy? What's the tube material? The tube. Y'all can just say it if you want. You got it. Yes. So the housing is lead and the glass is Pyrex.
Filament.
Yeah, we can go on if we want. See how it makes a conversation? The filament,
Connected to the cathode.
Yes, filaments in the cathode, right? What's the filament about?
It
This is the electron.
Y'all listening? The filament heats up.
Yeah.
What's the term? Thermionic emission. They're boiled off specifically, right? Yes. How many filaments are in the cathode? It's 2. Small and large. Good. Yep. Okay.
It's almost like a light bulb if you think about it. The filament is sort of a light bulb.
Right, it is. So I guess same concept. Yep.
Also,
Okay, Sydney has something else.
it's also a diode.
It's also a diode, right? Giving away answers for later, but yes. Okay, next group. Y'all just looking in your books. Y'all are cheating. Okay. Next group. Who's next? The back table. What's PBL? Okay, let me ask y'all this. Don't tell them yet. We're gonna help each other out. Do you know what it has to do with? Any word, anything, and if
Oh, does it have to do with the CR?
Is what?
I was,
Beam limitation.
yes. Okay, you're close. It is. It's a beam limiting device. Is collimation a beam limitation device? Yes.
It's part of collimation.
It's part of collimation. So you see how they're getting there?
I think it's automatic.
It's automatic collimation. Bam. Positive beam limitation. Positive beam limitation. Yep. So this just shows you, oh, what do I know? What don't I remember? You know, because I know it's a lot of information, but between the study guide and this, and y'all will be fine. Okay. Because y'all have the digital receptors down.
Yeah.
Word dumping, all that.
Yeah. How many different words there are.
I'm just gonna.
For what?
For the different things.
No, long as you make your categories. Have you made your categories?
Word dump.
Have your categories and then practice. Yeah. So if I call out a word, if I say, I'm gonna let Sabina answer. If I say selenium, what comes to your mind? Direct. She said Selena. Yes, Selena, but direct, right? If I say TFT.
Digital imaging.
I want Sabina to answer. You said what? Digital, but both,
Indirect.
right? Indirect and direct, because it's the 2 T's. Y'all remember that? You see your clues? Make clues for yourself, Michael.
CR.
Okay, Michael said CCD. CCD. What does that go with?
That one goes with indirect.
Indirect. See? Yeah, y'all got it. Now that I think about it, CCD has 2 letters too, right? That are the same. Okay, so stick with TFT is in both 2 letters the same. Don't get that mixed up with CCD. I just realized that. Okay, so this group, what is AEC and what does it control? We'll see where their thought process is first. Because you're all learning this stuff. It's fresh, right? It has to do with exposure in a way, yes. Automatic exposure control. So y'all are working together. It controls one thing really. Exposure. MA. So what part of the MAs?
Oh.
MA?
Y'all know it.
Yeah,
Not the S?
It is the S, the time.
Okay.
So write down AEC is automatic exposure control.
It's timing mechanism.
Yep, it's a timing mechanism. It controls the time.
Automatic exposure control?
Yes, automatic exposure control.
And it's
says you want the lowest time possible, MAS, and S is the time.
Remember we said why do we want the lowest time possible?
Lowest
exposure. Less radiation.
Less radiation, because we get it quicker, and then less patient motion, because we get it quicker, right? Does that make sense? Okay.
Just controls the time.
Just controls the time. We control, remember all of this is in the console. I don't want to give away questions, but we control KVP, MA, SID. AEC controls time. We can do time manually as well, but AEC controls time. Don't forget it. AEC is a timing mechanism. I see y'all. When you press the button, I'm glad y'all are so excited. When you press the button, y'all will do it soon, Monday. But when you press the button, you don't stop it. It's the AEC stops it. That's the timing mechanism. That's AEC. Make sense? Yes?
Is it different for every exam?
Yes, good, because for T-spine, y'all will learn, it's because you'll hear different beeps. You'll hear a beep, and then you'll hear a longer beep, like for T-spine, you'll hear a beep. And then when we hear a beep, we're like, ooh. All techs do that because we're like, ooh, that sounds like a lot of radiation, right? Because we want to beep. So you'll hear the different sounds. Most of the time, you'll hear a beep, okay? But that's the AEC that stops it. I'm coming to you, Emily.
And that is built in by the company, the manufacturer?
Yes, it's built in by the manufacturer.
Okay.
Emily?
And you said that the anode has two filaments?
The cathode. So remember, filament is only associated with the cathode. And there's two little filament springs. Y'all don't let me forget, Amanda, don't let me forget to show y'all the tube because it has the filaments. Okay, so I can show y'all what it is. Just two springs.
Like with the, like you see the light bulb, you can turn on one, and then you switch it, it'll go like brighter. Those like the two settings.
Right, yeah.
Because this really what is like a diode for a light switch.
Right.
Much stronger light.
Right, and then even students with like electrician background, stuff like that, when they come, it starts to they kind of correlate like that. Like, oh, this is kind of similar to that, especially when we start talking about the circuit.
That correlates with the focal spots?
Yes. So, cathode, inside the cathode, we'll talk about the part, so I don't want to go too far, but inside the, y'all listening, Amanda? So, in the cathode, there's two filaments, small and large. That correlates with the small focal spot and large focal spot. So if you're doing a hand, the small focal spot will be activated. Does that make sense? Okay, I don't want y'all to miss nothing. It's a lot of information. Okay, all right, good. Y'all got that. Okay. All right, who's next? No, don't look. Close your eyes. Okay, see, I just gave it away. Easy peasy. What can you do at the control console?
Click the button.
You can. You can click the button.
You can control MAs and KVP and SID.
Right. So MA, really, you can control time too, but AEC for time, SID is really out there. But yes, you can do all that.
See the picture too.
Yes. Now let me ask y'all this, since y'all had it easy. What is the acronym? You could say the whole word or the acronym for when you select, okay, I'm doing a chest. What's that called?
A. Something study, right?
Huh?
Something.
Not study. You got the A right and the letter S right.
ASE? No.
APR. Remember? Anatomical Programming Radiography. Y'all remember that?
Yeah.
APR is when you're selecting chest or foot or whatever. That's your APR. So APR, Anatomical Programming Radiography, that's picking the part. Even if you just put that down, that's picking the part. And then AEC is controlling the time, right? Okay. All right, y'all got that? Got it? Okay. Who's next? The back table?
Yep. What was it? ARP?
APR.
APR.
APR. Suboptimal MAs can result in what kind of image? Noisy. Everybody agree? Scatter that's what scatter is, right? What are other names for scatter and noise?
Quantum model.
Quantum model. Good. And quantum means a number, right? And model means grainy. So, yeah. Okay. questions about that? All right, group 1 again. An increase in MAs results in an increase in, how would you finish that?
Increase in amount or quantity.
Okay, that's one. Let other people answer too. So quantity, good, James. What else? What are other names you can tie to that to answer that statement? You said quantity. Think about our list we made.
It's an increase in current.
Increase in current, good. That's a really good one. What else? What goes with current? What is the current really?
Decay.
The electrons coming across. The quantity of electrons is your current. And then what else? Maybe one more thing.
Photons.
The number of photons, good. So an increase in MAs results in an increase in number of photons coming out of the tube, the electrons going across the tube, because ultimately that ends up in photons, right? The quantity, that's another thing. Y'all got
I
that?
have a question.
Mm-hmm.
So does the increase in MAs not also increase scatter?
No, remember, an increase in MAs helps scatter, clean scatter up, right? Because remember, right here, suboptimal, what's sub mean? Below. So low MAs results in scatter, but when we increase,
Because it increases IR.
where am I at? Oh yeah, when you increase MAs, then you can clean up scatter. So increasing MAs reduces scatter. Y'all got that? Increasing MAs, because if you know that, I see y'all, if you know that low MAs increases scatter, right? No, not really.
That part's not clear.
Okay, gotcha. And it will. It's gonna come together. So, a decrease, if you don't have enough MAs, you're gonna have more scatter.
Okay.
Okay.
Is it like the starts with the C, the classy coherent thing?
Not really. So I'll say this. I don't want to go too far because y'all are only limited to a certain amount of information. I'll say this. An increase in KVP increases scatter all the time. Okay. So the more because that KVP has to go, even though it's good penetrability, you still have increased scatter. So as you increase the KVP, your scatter is going to increase. What can help offset that is an increase in MAs.
And why do we want low MAs and high KVPs?
To reduce patient dose. Because think about it, when you have high KVP, that's energy, right? So that's more penetrability, y'all agree? So that's getting through the patient, not just stopping in MACI and absorbing and all that stuff. MAs, now, increase in MAs actually increases patient dose though. It helps us with our image, but it increases patient dose. So that's why our combination of technical factors starts off, this is what we want all the time, is a high KVP and low MAs. That is our LARA. Because high KVP decreases patient dose. Low MAs would do the opposite. High MAs would do the opposite, so we keep it low. Yep. So we don't want low KVP because that's not penetrability.
Yeah, that'll get filtered.
And we don't want high MAs because that's gonna get stuck inside of the diaphragm. Okay. It takes time so we're gonna go one step at a time, but I like that y'all wanna know. Does that make sense?
Kinda. I can see the KVP part.
Yes.
Which is the MA, I guess.
Yeah.
But I can remember it.
Yes, remember it and it's gonna start to make sense. Okay, let's go here first. Amira.
Yeah, does increasing MAs and KVP, so does just increasing MAs increase intensity, or does KVP also increase intensity?
Remember our list. So an increase in KVP and an increase in MAs increases the number of photons. But what's the difference between the increases?
One is
Yeah, I remember.
the penetrability.
Okay, yes, that's good. But also as I increase my MAs, trying to see where I was going here. That was good. Because you picked that out of that. What did you ask me, Amira? Cause he got me with that, but he did good.
When
What'd
you
you
like
ask me?
increase MAs, it increases the intensity, but does KVP
Yes.
as well?
Yes, but at a different rate. Remember I said that? And I think I had y'all write down the formulas. So as I increase my MAs at the console, the quantity of photons increase in direct proportion. Y'all remember that? And then as I increase my KVP at the console, intensity increases in proportion, but not at the exact same rate.
How would you write that down?
So, you want the formula? Because I want your eyes to see it.
Yeah, sure.
So let's do MAs. Y'all wrote it, but I want to remind y'all, and then I'll answer y'all's question. So MAs 1.
The whiteboard.
Okay, I can do it. Yeah, I can do it. Y'all want me to write it?
Yes.
Where's your okay. All right. So, MAs 1 over MAs 2 equals I 1 over I2. You see how the 1s are here, the 2s are here?
I don't think we've ever written that out.
Write it down. Did anybody not write it down? Maybe I said don't worry about it. But I'm saying this so it'll make more sense in your head. So if you didn't write it down, that's okay. So I'm not gonna test you on this, but I thought I did have y'all write it down too. Okay.
It's just good to know.
Well, because Amir's asking about the relationship. So, or why, or how it increases intensity.
I thought it was because KVPs do both, but focus on one and one. MAs only do one.
I don't know. Say, tell me.
Is it K
I
capital or
had
is it B
it
capital?
written down somewhere.
It's the V.
Okay, I'm sure.
Okay, look y'all real quick.
KVP does quality and quantity. MAs just do.
Yes, y'all remember that? MAs with our chart. We can go back to the chart. MAs is the #1 controlling factor of intensity. Y'all remember that? So quantity and all that. MAs cannot control what? Quality. Cannot control quality. KVP can also control intensity. So quantity also goes under our KVP list, right? But at a different rate. You see this square? It's not exactly proportional. I just had to show y'all this so y'all will know why this is the #1 controlling factor for quantity, because this is directly proportional. This can still control this, but this is the #2 controller. Y'all got that?
Is the formula the same as MA's reciprocity?
No, leave that alone right now. Don't look at that. Yeah. And I know that's what I'm saying. There's a lot in the chapter. Just like Miss Produced chapter 1, y'all had to skip a lot because y'all learned a lot of that in my class. So this is just patient care. So there's some stuff you need to know, some stuff we can wait. But I just did this because of mirror act. So don't let me confuse you. But does this make sense? Just ask to why. Because y'all are smart. So y'all are asking questions beyond where I want y'all to go right now. But I do want to make sure y'all get it. I don't want to leave y'all hanging.
KVP is reverse.
What you mean? Say it all the way. What you mean reversed?
The inverse.
No.
Small.
I think it's more like.
Now hold on. Let me answer her. What is the inverse square law? We're gonna keep concepts separate. What's the inverse square law talk about? It compares what to what? Let her answer, y'all. Distance to the, yes. That's all. Put a bow on it, right? Okay, does that make sense, Emily?
And then increasing MAs would increase IR exposure.
Yes, because our exposure, if I wrote the word quantity, can I erase this? Y'all got it? Okay. I want my whiteboard. It's okay. If I wrote the word quantity, what are different names that go under that, y'all?
Ooh,
He said, ooh, he's
I
excited.
remember this.
Yes, MAs, what else?
#1 controlling factor.
Uh-huh.
Intensity.
Exposure.
Yeah, exposure, y'all did all this. Signal value.
Time.
I said y'all can write down time.
Oh, I didn't write it.
I didn't put it.
Don't put time, yeah.
Okay, don't put that.
Yeah, let's leave that separate.
I put
What else?
intensity.
I mean, it is, but it'll make more sense later why we won't put this. Yeah, intensity.
Number of photons.
number of electrons, right? Because eventually that's gonna turn into, does that make sense? Yeah? Okay. So I'm gonna answer your questions, because y'all go far. I'm gonna reel you back in when you don't even know it, but I do wanna stop and answer what is gonna apply. Okay? Even if I say don't know those formulas for your test, but I want it to make sense to you. Okay, the difference.
MAs isn't spurred, but KVP is.
Yes. Which is why you see why. So which one, just looking at the formulas, Emily, you got those two formulas written down?
Yeah, I'm writing it down.
So which one looks like it would be a number one controlling factor of quantity? They both control quantity, but based on the formula, why would one be a primary over the other? Because the one is directly proportional. That's why.
Directly means not squared.
Yes. So what happens to one side happens to the other side.
So MAs is direct and KVP is indirect quantity.
So remember, under our list, we have, remember the MAs and KVP chart we made? Quantity goes under both of them, right? But let me, how do you have the formulas written down?
I did MAs 1 over MS2 equals I1 over I2.
Right, so that's directly proportional, right? And then this one you have right, but you see the 1, 1, 2, 2. That's directly, but at a different rate because of the square. So a different rate than that. So number one controlling factor of MA's control was intensity first. KVP.
So there was like not much that was just.
So we'll talk. I just wanted to show you that. But we'll talk.
So
just put
them all out.
Yeah,
And now they're-
but at a different rate
They're in a binder.
because of the square for
And like
KVP. Okay? We'll talk more about it.
I was thinking like, you want less, so MAs is easier to get it less, but KVPs is harder to get it less.
I don't want to confuse everybody. We'll talk offline because I got to see where your head is. Okay? Does that make sense though? Any more questions about that? Besides y'all's, y'all hold it there, okay? Y'all got it? I'll clean that up later. Okay. All right. So what group are we on? I like y'all's discussion.
I do.
Number 2.
This is a question about x-rays in general. So when you were talking about how when they come from the beam, hit the patient, and you become irradiated, especially your bones, and some of it is absorbed and some of them goes through to the IR, right? I always wondered, like, I don't know, so what makes the bones show white? Is the absorption? Remember,
Continuation?
remember absorption, yes,
Okay.
makes the bone show white.
Yeah. And then my question is though, how does that, when the stuff is absorbed, how does it go reach the image though? Like how does it create an image if it's absorbed?
Remember I said that's confusing for students? So you kind of have to just wrap your head around. We have absorption, so some has to stay in her, and then some has to transmit. That is our contrast. Because what's contrast? The difference in grays. We have to have, because if it was all transmitted, it would all be black.
Yeah.
Right? So don't think outside that box. Like don't go there with your head. Just know that it's all our eyes are visibly gonna see it on the monitor, but I see what you're saying. But you can't go there. You just gotta say, it's all on the picture. And I have absorption and transmission and I see it on the image. Y'all see what she's saying? That can be very confusing. It is. But we just know we see it and we know there's absorption that stays in, transmission, and you gotta just put a bow on it. That makes sense. So I got y'all. I'm gonna stop y'all and say just put a bow on it because it gets confusing and students ask that all the time.
So I guess a quick little example, I don't know if this will work. Like say you spray paint your hand and you see the electrons that hit the paper.
Like the remnant kinda, yeah.
And then what stays on your hand is absorbed.
That's a good point. Does that help?
Well, yeah, in a way, but it's kind of different.
Yeah, but you don't need to don't go there. Don't even allow. It's like, don't even allow it. Almost like when you have thoughts in your head, don't let them thoughts come to your head. Like, I can't do this. Yes, you can. Same thing with this concept. Absorption, transmission, leave it. Right? Okay.
I thought the bone showed white because the radio opaque.
It is, it's radio opaque, but the bone shows it white because the radiation is absorbed. Yeah. Okay. Which is what increases patient dose, right? So leave it like that. Okay. Yep. Make sense? Y'all got it?
Yeah.
Okay. All right. Who's the next group? First group?
Two. You just went.
2. Y'all just went. Y'all did. Okay. 2. All right. What is thermiotic emission?
We did that.
Can we skip this one?
Okay. Okay.
Did everybody know that before we skip it?
Y'all know thermiotic. We said it. Y'all know what thermiotic emission is? It boils off of electrons, and it happens where?
And the filament.
At the filament. At the filament. The diode. Filaments in the cathode. So filament is more specific. Yeah, they may not put cathode and filament in answers, but if they do, what's the best answer? Right. Yep. And you'll just say, well, I know the filaments in the cathode, right? You're gonna know that.
I be kind of quizzing myself, and I do the day part. They do that all the time. They put all that stuff in there, and you gotta pick the best one.
Right. You gotta pick the best one, yep. And so that's how we're gonna test you, because we would be doing you a disservice if we didn't. So it's not trickery like I used to think when I was a student. It's really not, it's to prepare you, so I promise. Okay, Amanda's group?
It's not trickery.
It's not trickery?
Right now it is.
A little bit. Y'all's group? Is it y'all's turn? Yeah? Okay. Radiolucent versus radio opaque, that's spelled wrong, but explain it.
Radiolucent is like more sweeter.
Yes.
Like translucent, but you told them not to think of it that way. Though it's not the same.
Yeah, if it helps, you can, as long as you get it right. Yeah.
And then opaque is like more white. Like not as super.
Right. So chest X-ray, your air would be which one? Right. Radiolucent. Everybody agree? Okay. So y'all, everybody solidified that. You put a bow on it. You got it. Okay. Good. So what I don't want y'all to do is to skip over stuff just because you don't understand. Oh, she might not test us on that. No, go by the study guide, go by I know that PowerPoint is long and I cut a lot out, but go by the study guide, whatever other resources I have. Ari, you raised your hand? Maya, okay.
I was like, with those two, it was like radiolucent goes with low attenuation.
That's good. So she's going further. Okay, so what is low attenuation? Maya, what does that mean?
Like when you brought up like the air, like that would be low attenuation.
Right. Right. And remember, I said for testing purposes, you can almost scratch out attenuation and put what there?
Absorption.
So low absorption would be translucent, right? It gets to the IR. A lot is not absorbed. You see how that works? That's that's a trick, not a trick, but that's like a hint. That's like to help you.
So could you say like increased IR exposure?
Okay, so she's going a step further. Y'all listen back there, so y'all won't miss it. So Amira, say what you just said. I see
like
it,
radiolucent, like increased IR exposure.
Okay, so radiolucent, Amira, why does radiolucent increase IR exposure?
Because there's less absorption.
Yes, less absorption, right? So if something is being absorbed, that's going to be less that gets to our image receptor. Got it, James? And then I'll get to you, Kyra.
I was gonna say with the X-ray, it's like water is. It's like a strainer if you're thinking in the spray paint sense. So that's why it comes up as like gray-ish, but then air is clear. So when you're like looking at the lung chest ray X-rays, it's just black because it easily goes through air.
Right.
Your bones are like a brick wall.
Right.
So it's
Yep.
gonna go through it.
Yep. So use all these analogies, whatever's gonna help in the real life to share them to help you. Good job. Okay, so who's next? The back table?
Yeah.
Okay. All right, what are the names of the diodes in the X-ray tube?
Cathode and
It's not y'all's turn. Y'all are so excited though. I'm so excited. Y'all are like into this. Yes, and I don't think they heard you. Y'all got it?
So it's passing through.
Huh?
The positive and the negative creates the voltage so that the electrons go to the anode.
Okay, but what are the names of just the diodes?
Oh, the cathode and the anode.
Good. I like the explanation though, but yes. Anything else y'all want to elaborate on with this? You just did really, right? Good. Okay. All right, y'all. Ooh, fun. Nobody answer. Hold on, Kyra.
About the last question, so radio opaque, is that high absorption then?
Yes.
Okay, and does it decrease?
But is it high attenuation?
Yeah.
Yeah, because you could substitute the word. Michael, you said no now. You got it? You just gotta process it.
Repeat what you just said.
I forgot what she said.
And then does it decrease IR exposure? Is it just the opposite?
Okay, this what? Start over.
Wait, which part, the attenuation or the IR exposure?
Or just say what you're asking. I didn't hear you.
Does it decrease IR exposure, radio opaque?
Radio opaque decreases IR exposure,
Okay.
right? Okay. Radio opaque does blank, radio opaque blank attenuation.
High.
Increase.
It decreases attenuation.
Increases. So radio opaque, bone, right? Blank attenuation. Remember I said put,
Absorption.
Right. You see how? Because y'all know what absorption is, but it takes on two different, it's the reduction in intensity due to absorption or scatter, right? That's kind of lengthy, but when you cross that word out and put absorption, it's just so much
I'll
easier.
get it right when I see it.
Yep.
That's what I do. When I say
Uh-huh.
attenuation, I just put absorption.
Good, because you overthink it when attenuation's there. Do y'all understand that?
Yes.
Okay, you got it, Sheridan? Okay, all right, good. All right, so y'all's group, what you got? Y'all say loud your thoughts. Say your thoughts out loud. What'd y'all say?
It's the
Come on,
outer
extra.
shell electron, which is Compton because straight out of Compton.
There, see, bam, bam. You cannot go wrong with that. And y'all will learn other interactions. Remember, I told y'all the interactions with the anode. This is the only interaction that is the outer shell. So when students put Compton goes with inner, I'm like, I want to scream. So I'm gonna scream. I told Miss Purdue I'm gonna come in here screaming one day, but I don't want to scream because somebody's putting outer shell with something else. Don't do. It's the only one. Y'all got it? Y'all are gonna hear my voice and test and saying it's the only one, so it's got to be Compton, right? Only outer.
I started thinking of it as only Compton, so I started saying like they're taking photos inside of Compton, and that makes me remember it.
Okay, now the only thing that can present is photoelectric. Students may get, so if
Or
you
photos
remember it that way.
Yeah.
Oh,
photos
you're saying
inside
for
of Compton.
photoelectric.
Yeah.
Oh, say it.
I said I remember it by thinking of it as like they're taking a photo inside of Compton, so inner layer inside photo.
For photoelectric absorption?
Yeah.
Okay, yeah. That's a good way to remember photoelectric absorption. Yep. All right, good. So anything else we need to say? What is the process? What things can you say, this group, about Compton? What can you say about it? What are some features of it? Just this group, because y'all get excited.
It doesn't cascade.
Okay, good. It does. If we wrote notes, right? Y'all want to go right? Go right. Go ahead. You just talked. She said we're good. We just talk. So y'all write that down. It does not cascade, right? Okay. What else? What else y'all got? They're like, oh, I gotta say it. I gotta say it. I see them like they're trying to hold it in, y'all. What else?
It just causes scatter, not absorption.
Yes.
And like because of the cascade,
No cascade.
or because there is no cascade, there's not the like
The X-ray that's produced. That
right
Uh-huh.
the effect of that you get with the absorption.
right. So you see how she's linking these things now. She's saying it doesn't have cascading, so you're not necessarily going to get that X-ray that's produced. You may get other things. There's things that are going to go on because this is going to go on to do something. But let's talk about the difference in these energies. Let's talk about that. What you got, Nadira? They're killing themselves. Like you should see them behind y'all.
I think Michael just.
No, yes you do. Okay, let's talk, what is this called in the diagram? What's this one?
The primary beam.
So, okay. You can kind of say that, yes. Or the incident photon.
about saying that.
That's not wrong what you said though, primary. So this, just to make sure we understand, because I backed up last time, I don't ever want to think, because sometimes we're blah, 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 because we, but the x-ray tube is here. This is your patient, literally, right? The photon's coming out of the tube, it went through filtration and all that. Now, like she said, I like that you said that, that primary beam is hitting your patient's atom. Everybody got that? So I want to make sure. So this is an incident photon. Don't y'all say electron. Don't say that, right? Incident photon that's coming and hitting your patient's atom. So just based on the lines, what's the difference in the energy? Because anytime, what's low?
The energy is low.
The energy coming out is lower than the original energy, right? How do you know that just by looking at this picture? The waves? Okay, explain the waves to me. Longer wavelength? Right. Higher frequency? Shorter wavelength, higher energy. You see how y'all are connecting those now? And then just think, like I said, if you're running, you're gonna lose energy. Right? Anything that goes through something is gonna lose energy eventually, right? Okay? If you hit a wall, a lot might happen, but yeah, you're definitely gonna lose energy,
So number 3, that would be called the scattered photon, right?
That would be your scattered photon.
So you can write it like the scattered photon has less energy?
Yes. Than that original, what came in.
You knock that electron loose.
He said it knocked the electron loose. What's the electron called now?
Recoil.
Good, because I said anytime you see recoil, that goes with Compton. Remember that? So I'm giving y'all clues, so go home and connect them, okay?
Because it's scatter, it affects us more.
Good. She went on and on. Yep, perfect. Because it's scatter. Scatter's going to affect us more. So that is all your word dump under here. Okay? Y'all got all that word dump? Anything else we missed?
Like Sydney said, it's the largest source for radiographers.
You better say it, yes. Well, yes, but then let's back up. Who is the source of scatter?
The patient.
Yes. What is the nucleus made out of?
Neutrons.
Protons and neutrons, electrons on the outside. What's the charge of the neutrons?
Neutral.
Neutral, right? What's the charge of the protons? I was about to say photons. Protons, positive, right? Yes. Electrons, negative. What's the atomic mass of the atom? Since y'all know everything.
The number of protons plus the neutrons?
Yes, we'll go over that. But yes. I just wanted to pick y'all's brains. I won't have that on your test. Okay, next group. Who's next? Y'all? What is the largest source of radiographic noise, artifacts, Compton, focal spot size, motion, object size?
Motion.
Read it carefully, slow down. Just this group. Say it in y'all's head, but y'all come. Make sure y'all talking to each other.
How do you classify artifact size?
Like things.
Anything that's not supposed to be in the image, like it can be a belt that wasn't taken off, a bra.
So scatter.
It's scattered.
Artifacts can be seen.
It's scattered.
Okay, they say be scatter. Everybody agree? Oh, hold on now. Amanda's like, Okay, what you think, Amanda? Okay, she says motion. Okay, anybody have that answer?
All of the above.
All of the above. Okay.
I say because it says radiographic noise, if it's talking about noise, it's usually specifically saying scatter rather than motion. Because motion would be like blur from movement.
Okay, let me stop you there. Cause let me stop you there. I like the first part you said. You took out noise and you put scatter because you know that's the same thing. You got the answer wrong. It's not motion, y'all. But I like that you did that because that's gonna do something with our answer. So
I said it was scatter.
Okay, you said it's not scatter.
Focal spot?
Is it the object size?
It's the object size because who's the source of scatter?
The patient.
Yes, you see applying A different way of saying it? I love this question. I almost said, I don't want to show them this because I want to put it on their test. But I knew y'all was going to put B.
So put it
You
on
can still put it on.
No, y'all are good now. No, y'all are good now. Y'all are going to get it right. Huh?
But doesn't the patient cause the scatter? So wouldn't that be the same thing?
It's because
The source.
Mm-hmm.
That's the key word. The source of scatter. Just like I asked you
Okay.
before this slide, who is the source of scatter, or what is the source? It is the patient is the object. Isn't that cool? I love this question. Y'all are like, you're nuts. But I love this question. So let me tell you why it's not motion. What word goes with Ari? What word goes with motion? You said it the other day. That's why I asked you. You remember? You just said the definition of something else I asked you. Remember, and this may be too far. Y'all may not, it may not be clicking yet, but spatial resolution is what?
Sharpness.
Sharpness. So if the patient is, if you have unsharp edges, it's usually because the patient, you have motion. So that's where spatial resolution comes in. Those are connected. Also called penumbra is unsharp edges. You can have scatter and still have, you can have scatter and still have sharp edges. You can have scatter and have motion. Motion goes with, that's low spatial resolution. Okay? Scatter goes with,
Were you not teaching?
Oh, what we doing? I don't know. We're reviewing, but they're good. They're so good.
It was getting good.
You're gonna be
It's
good
getting good. Because they're making it good. They're asking questions based on the, they're good.
Call me. Okay.
It was a little chilly, but we got moving now. But look at this question. This is a good question. And you know what? Now I want them to explain it to you.
I want you to answer it first.
Oh, they said they want you to
Don't be testing me, sit.
Look, and y'all don't ask me about her stuff, because she shows me y'all's quizzes, and I take them sometimes before y'all take them, and I'm like, I make C's and B's on her stuff. I do okay. Addie.
Largest source of radiographic noise.
Look, if she gets it wrong, can we get bonus?
No.
Compton. Scatter.
She didn't answer yet. She's still
I'm
thinking.
thinking in my head.
She's doing process of
Y'all
elimination.
can't help
Right. The largest source of radiation is the patient. I just had to go through the choices, okay?
But isn't it an awesome question?
It is.
How it's worded?
And then it doesn't say patient. So the object.
Yeah.
So what are the articles?
Woo-hoo.
Artifacts can be like if a bra is left on, anything that's not supposed to be in the image.
That's a register question right there.
That's nice.
Largest source of radiographic noise, or it may say radiographic scatter, or
Quantum model.
Uh-huh.
And I said I should have put this on y'all's test and I showed it to y'all, but I wanted to show them how we teach y'all, and now you gotta apply it. We can't give y'all every way to word it. And I told them it's not trickery. I thought that, but when I got to that registry and I did well, I knew that it was all for a reason. So
You gotta know
just
all the
trust us.
synonyms of the word.
Yes. That I know that means this, this, and this, and they made their list too with noise. So they're doing really good.
Good.
They're doing good. So
Okay, so
they're
you owe
teaching
me,
me.
Sydney.
You owe her a point.
I got it right.
You must have heard us in here. What'd you say? It's 9:30. What they doing?
Everybody staying for my review?
Yeah.
Ooh. Ooh. Everybody. Okay. That's all I came to ask.
A study guide too, like.
Oh, listen, Ari, listen.
Now, Ari, in my defense, in my defense, it's just because of those chapters. And I even hate that they dump everything in there, but y'all have to have some exposure to it. So that's why all the other chapters I haven't really made a study guide, unless it's, I don't know, vocabulary assessment or something. So,
While I'm in here, I may say, okay, make sure you got this. Would that work? That work. Okay.
I'll take
So I don't want to type nothing else, so I'm typed out. Okay. All right.
Uh-huh.
So we're still gonna highlight chapter 13.
Yes. good. We got time. We're in here till 10:30, so we'll get there. Okay, so who's next? Y'all? Okay, so let me ask y'all this. I'll help y'all with this one. What are the 5 interactions of matter? That's y'all's group. Ooh, y'all got it bad. She's like, photoelectric, Compton. And those are the 2 out of the 5 that are seeing a diagnostic imaging, right? Y'all got that?
It's
Pair production. Y'all want to help?
Photodisintegration.
Classical, which is also called coherent, and there's other names to it we'll talk about later. And what's
Photodisintegration.
photodisintegration? So, out of those, which one do you think this is?
The one.
Is anybody able to use it?
Yeah, anybody can answer.
Photoelectric.
Yeah. Right? Yeah. Photoelectric.
Now, you're saying that because you see the,
I've never seen
Or
this.
you saying?
I mean, it's cascading,
Yeah,
so
because
it looks
they're
like
pushing
photoelectric.
and emitting
But it's also saying that those are going
radiation.
out.
Yeah, but those are creating the radiation because of the
Oh
cascade.
yeah, oh yeah, it's producing X-ray.
Right.
okay, so y'all think it's photoelectric. So what is,
Well, it's not, cause your face says it's not.
No, it's photoelectric.
Oh, shoot.
I gotta exit out.
You can move the picture.
Or use the
This is
bottom,
different.
like the arrows
I
at the
don't think
bottom.
that's the same
It's
picture
a
we were
different
just looking
picture.
at.
Yeah, it's not.
It's not, I'm like, wait,
This is
that don't
the,
look like it.
the
Wait, go back
coherent.
up, number 14.
Dang, I'm about to show y'all everything. Hold on.
We can
You,
Go,
it's 14.
go up.
go up 2 more.
Oh, okay. Alright, so what is that?
Incident photon.
Y'all saw it.
Click it, and then there's an arrow that pops up at the bottom.
The 4 arrows at the bottom.
And move it there.
There we go. Okay, what's this?
The
Photoelectron.
Yeah, photoelectron.
Ejected photoelectron.
What's that?
That's the K and stuff radiation.
Secondary
X-rays.
Yes. So what is this?
Photoelectric.
The last group, what do y'all think?
I don't think it is because they're not cascading down.
No, they got arrows going
But it's
down.
called the photoelectron.
Because it's the photoelectron, yeah. So it is photoelectric effect because you have the incident photon coming in, knocking out this inner shell, right? Photoelectron, and then you have the cascading. So secondary X-rays. So what are these called, secondary X-rays? Somebody said it earlier. Scatter, but what else?
K.
Characteristic or K, depending on, so which X-rays would that be called based on the shell that it came out of?
Like the name?
Mm-hmm. What kind of X-rays? Based on the shell. What shell is this?
The
Acacia.
acacia. Oh, the
K.
acacia.
K shell. Yep. So that is photoelectric.
So that's gonna be acacia vacancy for that one? For the-
Yes. K shell vacancy.
Also, that question I asked earlier, I kind of got the answer to it when I remembered this, because, and I don't, but I understood it like, okay, that's why when absorption happens, we still see the image on the X-ray beam because the ejected electron hits, or like, like you can still see how it transfers through. Like it doesn't just absorb and like stay in the body like the X-ray does, but there's still something that's hitting.
Right.
The
There's
IR.
another effect.
Yeah.
Right.
So like now I understand why it's lit up still, and like why
Right.
the absorption, why it just helped me understand. Like I can see it now.
So we were saying it. You just had to put it. Okay.
Yeah, like like at first I was like, yes, absorption happens, but when I remembered that the X-ray beam hits the electron and it still travels through that straight
Right.
line, it made me understand why, okay, this is why scatter shows up that way and why the actual image shows up this way, like.
I see
on
what
there.
you're saying, because we're saying photoelectric and Compton. You were wondering why. Got it. So there is some that just goes straight through though. There's no interaction with her atoms at all.
Yeah, that's what I mean. Like that's
Right.
made me understand it as well. Like the darker areas that they just go straight through there. They don't interact with anything. That's why it's darker like that.
Right. That's your transmission. Yep. So straight through, no interaction with her atoms is transmission.
Will you post this as?
I'm gonna post it.
Can you make it bigger?
Yes.
So the L shell characters gradation, is that the outer valence going into the second?
So it's just like a cascade and it keeps dropping.
So
And
the
the
first
X-rays.
cascade is L shell, and then the second cascade is A shell.
Okay, what do you mean by first? So counting, and we're gonna go over this. I think it's next chapter. Don't quote me, or the next one, where we're talking about atoms. So starting with the nucleus, that first shell is K.
Oh.
So K, L, M, N. Also 1, 2, 3, 4. Okay,
It doesn't have the fourth shell.
that's okay. Sometimes you won't see that. It just depends on what kind of atom it is. Okay, we're getting there. Let's move faster. Who's next? One. Okay, as a result of photoelectric interaction, what happens?
An electron.
Wait. Let everybody read it. You're so excited, but let everybody read it just to make sure. And then get with your team. Let's do teamwork. Yes, sorry.
It's okay.
Because I'm going to have to go back out
It
and look.
distracts me whenever I can see the like little box on the side.
Doesn't have the smile. Yeah.
We all agreed on
Thank
B.
you.
Okay.
Finished reading it yet.
Sabina. She said she did. Are you finished now, Sabina? Yeah, okay. An electron leaves the atom. Everybody agree? But you see how it's a lot of words, and you got to really read through them and know which one it is. Okay? This is going to be posted, so if y'all didn't read it. Yeah. All right, what about this one? Dang, that's showing a little bit. What about this one? Who's next? Y'all? Addie, y'all get together. Kyra?
The one before that, why was that not like, why was it that?
Because
that's,
what-
it's talking about the photoelectric, and that doesn't mention anything about the electron.
Well, what happens to the X-ray with photoelectric? What happens with it? I want her to think about it for a second.
Like, and then like, it happened to it like.
So if the photoelectric effect, that X-ray photon comes in and hits the inner shell, and then what happens to that photon? What's the purpose of photoelectric? Y'all can help. You want to tell?
It's connected with electron.
Hold on. What happens to the X-ray with photoelectric? It's absorbed, right? So this says the incident X-ray leaves the atom. It doesn't. It's absorbed, right?
The electron.
Right.
Okay.
Yeah. Y'all see that? So these little words, you got to go back and say, okay, what's the process of it, right?
So I guess, could you take the H-ron and just put photon, so that way you know that's the photon going?
You can if that helps you. The incident photon instead of just putting the photon, you can.
So that way you know.
And then the
it's
X-rays that come off as well.
Yeah, you can, Amanda.
Cascade.
Or wait,
No.
no, because you said it's absorbed. Never mind.
Well,
Right.
It's all.
It's absorbed. The X-ray is absorbed, right? Okay, who's next?
Cascade causes more.
Addie's group, what's that? 5 interactions, photoelectric, Compton, coherent, photodisintegration, pair production. Okay, let's eliminate. Is it ionizing? Just this group. Is it ionizing group 2? Okay, so which ones does that throw out? Does it throw out Compton? Yes, because Compton ionizes, right? An electron is removed. Does it throw out photoelectric? Yeah, because this ionization. How about coherent? Does coherent ionize? Why? It's not enough energy, right? It's only 10 keV or less. So there's not enough energy to ionize. So incident X-ray comes in and then it goes out. That's it. Okay? All right. Last table back there. Oh, okay. Photo disintegration. So incident photon comes in, it's gonna mess with this nucleus, disintegrate the nucleus, and then it's gonna release this particle. Okay?
So it's taking the whole
Yep.
nucleus and doing
It's breaking it down, and then this is gonna be generated. That's photo disintegration.
And that's for nuke med?
Probably
or
radiation therapy.
Radiation therapy, okay.
Kill cancer cells.
Oh, so
Hair
like you're killing
production.
the cell?
The incident photon is coming
That's the
in.
one where she was like, it automatically
It's gonna
kills it because it hits the nucleus.
release
I remember she said
an electron and a positron.
I know.
So it's gonna
Oh, I
release
guess,
those two
yeah, that
things.
makes sense.
Okay, that's the pair
That's-
that's left over from that interaction. Okay?
And then for the test, you said the only two that we really need to know, like picture-wise.
Picture-wise is those, yep. But I just wanted to show y'all this, yep. So know that the two that are seen in diagnostic imaging, but what did I tell you? You gotta still list, right? Or know all of the 5 interactions as far as in words.
Yeah, because it doesn't really explain the last two, the pair production and the photo
It does just as much as you need to know. It just says what I just said.
In that lecture video, you had, it explained it as well.
Yeah, just a little bit, yeah. But like I said, know for your test the pictures of the ones in diagnostic and then the list of the 5. Okay, y'all's group. What 2 radiographic units are measured in sievert? Y'all are all saying it.
Is this a group?
No, it's just this group. They're thinking. Y'all talk out loud though, your thoughts. Because we said one before and then we added one in lecture.
Exposure is the one that we've known before.
Well, that's not the sieverts one though, but that is the one that you knew before, yeah. Y'all need hints, or y'all still thinking?
Exposure and effective.
Not exposure. What does exposure go with?
Exposure.
Exposure goes with the radiation at air,
Dose
coulombs per
equivalent?
kilogram, right? Equivalent dose or dose equivalent, however you see it, write that down, and effective dose, right? So equivalent dose and effective dose are measured in sieverts. What do they measure, y'all?
How it biologically affects.
Very good. How it biologically affects the patient. Y'all got that? So equivalent dose and effective dose. It may say dose equivalent, same thing. Both measured in sieverts. They measure the biologic response based on the radiation that the subject was given. We'll get deeper into that and we'll go, because effective has 2 things it considers. Equivalent has 1. I'm not making y'all know that now. Just know the units and that they're measured in sieverts, the units of sieverts, and that they measure biologic response.
Wouldn't it be like occupational dose too?
Yes, occupational dose is that 50 millisieverts, right? Yep, good. And that was just an add-on, very, very good. Okay? We just said this. Y'all want to answer? What's your absorbed dose? We didn't say that one. What's your absorbed dose? Just group whatever y'all's number is.
Gray of tissue?
Gray of tissue.
Or joules per kilogram?
Good. Or joules per kilogram. Don't forget that one. If y'all haven't memorized that one, we added that one. Radiation and air, we already said coulombs per kilogram. What else? Sydney. Gray of air or good.
What was air carbon again? The exposure of something?
Radiation and air.
Radiation of air.
Radiation and air. Okay. Ooh, that's a good one. Back table, Stacy, Bree, and Kobe. What does the law of Burgundy and Tribendo refer to? Y'all consult with each other first. And then let us know if y'all need help. For stuff like this, y'all, it would be good, even for the units. Don't do flashcards for everything. You'll have a stack. But for definitions, do flashcards. Burgundy and Tribendo, do flashcards.
Can you go back for 1 second? Radiation and air. You're good.
Okay. Y'all need some help? Okay, we're gonna speed this up just a little bit. What's some words you could say that goes under this? Anybody?
Mitotic. Is it mitotic? Pregnancy.
Radio sensitivity
Okay,
of cells. So we're comparing
Strong cells or adult cells and baby cells.
dividing cells versus mature or not mature, dividing versus not dividing as rapidly. us versus peds patients.
Gray hair and then
Yes.
gray tissue
Right?
and
So that's Burgundy and Tribando. It says that
this is
specialized mature cells are more radio resistant, right?
Yeah.
And then rapidly dividing cells are more radio sensitive. That's the difference.
radio sensitivity and what?
Radio sensitivity of cells, that's what this goes under.
Okay.
Yes, Amanda, I see you too, Ari.
What chapter do we go over this?
Page one.
Page one.
That was the last. Uh-huh.
I just wanna make sure I have it clear, so the cells that are resistant that you had mentioned with like the nerve, the brain, like those are the
Yes.
ones that are resistant?
Yes.
Okay.
Good. So nerve and muscles, and that we're gonna go over it later too, and there's gonna be a whole chart that y'all memorize. But if you get that in your head now, that's good. Muscle and nerve are radio resistant. And brain. Yeah. But like gonads, that would be more radio sensitive, right? So y'all see that difference. Yeah. Good.
Just like with the, you have to cover your
Thyroid, right. Y'all got that? Okay. First group, talk to your group. What somatic versus germ? Because he's ready.
Go ahead, James, we trust you.
They trust you, James.
This one has to do with the chromosomes of everything. Has to do with just reproductive chromosomes, yeah.
Yep. So somatic of the body, germ, everything else, or reproductive, right? Got it? Occupational dose, we said that, 50 millisieverts. Okay. All right, radiation monitoring, what does the OSL dosimeter consist of? What, remember I said there's layers in one, there's crystals in the other. ATC, good. Aluminum, tin, copper. That's the layers of that packet. This is y'all's dosimeters, I have them today. I don't know which one this is, to be honest. This might be a OSL, I don't know. TLD, I don't know. But the packets are all similar like this, whether they're bigger or little.
And what does OSL stand for again?
Optical stimulating luminescence.
Yes, optical, right?
Optically.
Optically
Stimulating
luminescence. Write that down, because I forgot the exact wording. Okay, so ATC goes under this. That would be your word done. Aluminum, tin, and copper.
This is the one that we're gonna be wearing, you said, this particular one?
I gotta see which one this is. I wanna say, it might be a
It's
TLD.
the most common.
It is the most common, so it could be OSL. I think I've looked at it before to see, and I couldn't tell on y'all's paperwork, but maybe TLD, yeah.
Are we gonna get those today? Or-
Yes. Don't lose them, okay? TLD, that's those crystals. So look, and I said that's all you need to know for this is what it's made up of and what it stands for. Thermoluminescence dosimeter, is that what that is? Okay. All right, fluoro, I have some fluoro stuff. I said I was gonna do this review until 10, so we're still on schedule. The reason why I just want to show all of you this is because some of y'all will be going to fluoro. And I didn't want you going in blind. You're kind of going in blind anyway because y'all don't go over fluoro until later on. I don't know what semester with Miss Purdue. But let me just go here. So there's most common procedures that you'll be doing in fluoro. We know that fluoro takes what kind of images mainly? What's that word? Dynamic images. It can take some static. That would be your spot images, okay, where they just take a picture. It's called a spot image. So you know that. You kind of know the looks of it, how you can move the table up and down. Let's see. I just wanted to show y'all some studies that you'll be doing. Angiograph is really for like IR, so you probably won't be doing that unless they have some kind of special procedure and you get to go with them, but most likely no. You will be doing like barium swallows are also called an esophagram. They also could be called a cookie study. All of that would go under esophagram, James. So if you have a cookie study, you can comp on that and that can be considered an esophagram. Okay? And you'll ask me later like, hey, can I comp on this? I'll say yes, it's an esophagram. Now you can't comp on a cookie study or a barium swallow and an esophagram. They just have it termed different, but same comp, if that makes sense, okay? So they'll just run the barium. They'll have the patient drink barium. I'll show y'all in a real quick video. And then that barium will run down, and they'll fluoro to see their swallowing function. Like Miss Purdue not jokes, but she's like, you need to go get a swallow study because every time I eat, I get like I have a cough after, and it's probably reflux. I don't know, but I probably do need to get checked out. But whatever, that's neither here nor there. So I would go and get a test like that, a barium swallow. Okay, and then barium enema. Y'all have heard of that?
Yeah.
Okay, now we're going up the other end, the opposite end, right? And we're tipping the patient in order to see that large intestine.
Are they usually awake for that?
Uh-huh. Yep, and they're fine.
I was
We're
just
like, hold it in, as long as you can, hold it in.
Oh, Lord.
Yep. I've had a new barium enema before. And then cystography, do y'all remember what, it says it on there, but cysto, what is that med terminology? Cysto, it means bladder. Okay, cysto means bladder, so if they're doing a cystogram, what they're gonna do is put like a catheter in the patient, and then in the patient's urethra, and then they're going to inject contrast. It's gonna go up the into the bladder, up the ureters, and then they're gonna let it ureters, and then they're gonna let it come back out to see. It's called a voiding cystogram to see how their bladder drains. Okay, see if there's any dysfunction. You've seen that before.
I've had that before.
Oh, you have? Okay. Yeah. So to see how their bladder drains that urine. Okay. Hysterosalpingogram. This is one. It's termed the HSG. It's a hysterosalpingogram, but this is one where women will come in and then they'll inject contrast, have them in stirrups like if they're getting a pap exam, and then they'll inject contrast. Okay, and then they'll look at their uterus and then their fallopian tubes to make sure they're not closed.
Do you think we'll see
very, very, very sensitive exam. So y'all are not allowed in the exam, but y'all can probably help set up for it. Maybe help get the patient comfortable. Probably not. The techs are probably going to do that, but you get to watch it on behind the lead wall on the screen. So you setting up for it at Wellstar, that would be your comp. Anywhere else they do HSGs like doctors, I told them that you can comp if you set up for it, but you're not going to be in there. So don't ask to be in there. Very sensitive, and we just keep it like that, okay? But comping on it would just be setting it up. So easy comp, okay? That's your HSG. Myelogram, we're putting contrast into the spine. So you'll learn about how the patient should be positioned after the fact, and things like that. With some of these, there are actually x-rays, like still pictures that may be taken after the fact or before the fact. That's called a scout, okay? I just want you just a little familiar with a little bit of terminology, but they know that you come not knowing a lot, okay? And that is really it for that. There is also an arthrogram, not angiogram, but an arthrogram where they may inject contrast into the joints, okay? So that's another procedure that you can